All right, so this is actually take 2. As the first time I did this, it went too long and YouTube wouldn't accept it. So let's try and pick up the pace a little bit and get this here so YouTube can accept it. So we can put it up there. All right, Chapter 5, Section 1, we're solving inequalities. Nice thing about these is that inequalities are solved exactly like equations are. Not equations, equations with a Q. Okay, solved exactly like equations are. Our first step, as always, is to get the variables on one side and all the constants on the other. Okay. Second step, we need to combine our like terms. And our third step is to divide by the coefficient as always. That's just getting our variable by itself. So that's nothing new here. Let's get all those put in. Sorry, hate that they bubble up like that. But if you need them, go ahead and rewind it. So our next thing, we've got an example here. 4x plus 12 is less than x minus 3. We need to go ahead and get our constants to one side and variables to the other. I'm going to pick to move the variable to the left in this case so that I avoid negatives, and we'll talk more about negatives here on the next problem. But we can get rid of that x, so then I have 3x plus 12 is less than negative 3. Move my 12 over by subtracting it, and 3x is less than negative 15. Final step, there's nothing to combine, so I can move to my final step by dividing by 3 and getting x is less than negative 5. Okay, easy enough. Go ahead and save that in there. X less than negative 5. Now, this next example, we have a little special note to go along with this. When I'm dividing by a negative number, said we were going to talk more about negatives. Here it is. When we divide by a negative number, we must flip the inequality sign. So if it was less than, it becomes greater than. If it was greater than, it becomes less than. Okay? Now, in this example, just like in the first one, you can see that if I would simply take the 3 over, I wouldn't avoid negatives. Okay? But for the sake of the class and to see this example, let's go ahead and make a negative because there's sometimes you can't avoid it. So we're going to subtract negative 5x and get negative 2x over here minus 18 is greater than or equal to 20. Notice I didn't flip the sign yet. All I did was subtract. I didn't divide. Okay? So not until I divide do I flip my sign. So I have a negative 2x is greater than 38 at this point. Okay? Now is when I'm dividing. Divided by negative 2 on each side. Notice the negatives on the bottom. So when I say I'm dividing by negative 2, that means the negative is on the bottom. In the previous example, if you scroll up and look, or look on your notes, my negative sign was on the top, so I didn't divide by a negative. Okay? Here it's on the bottom, I'm dividing by a negative. Those cancel, so that leaves me with x being less than or equal to negative 19. Okay? So it makes a difference. You have to flip that sign. I'm saying it, I'm saying it, I'm saying it. Put stars on it, arrows, whatever you need to. Make sure you remember to flip the sign every time you divide by a negative. Okay? So let's take a look at another couple examples. As you can see in this third example, they're going to get a little tougher. We have some parentheses you have to distribute in. Remember back when we were doing equations and we had these negative signs like here, you forgot a lot to go ahead and distribute the negative signs. So let's not forget to do that this time. All right. So I distribute my 8 through first, and I have 8x plus 16. Distribute my negative 3 through, and I have negative 3x plus 12 is less than 5x minus 35 plus 8. Let's combine our like terms together. Notice 8 and a negative 3 gives me 5x plus 16 plus 12 gives me plus 28 is less than, I have a minus 35 plus 8 gives me 5x minus 27. Now we're going to combine our x's. What happens? 5x's, both of them cancel out, and 28 is less than negative 27. Now I take a look at that. I have to ask, is 28 less than negative 27? The answer, of course, is no, false. Do we remember what happened when you had an equation where the variables canceled out? I hope so, because when they have a false statement, that means we have no solutions. Okay? Variables cancel out. False statement was no solutions. I hope we remember that. So if you flip onto the back, we do a little bit more with that concept. When our variables cancel and you get a true statement, obviously it now becomes infinite solutions. And when it's a false statement, there are no solutions. And if you remember the two symbols, we used all real numbers when we had a true statement, and 0 with a line through it, the empty set, for no solutions. Okay? Let's take a look here at another example to see what happens in this one. Again, we have a negative sign in front of our parentheses, as you will see in probably just about every example I give you till we figure that out. But we go ahead and distribute that negative sign with your 3 to get plus 18 and plus 6. Now combine our like terms. Positive 3, positive 6 gives me negative 3x plus 9 is less than, I can combine 13 and 18 to get negative 3x plus 31. Okay. Combine our x's. Again, I see that 3x's cancel out. 9 is less than 31. That is true. 9 is less than 31. Therefore, our solution is all real numbers. Okay? Going quick. If you need to, remember you can always pause. Uh-oh. Don't know what happened there. Here we are. All right. You can always pause, rewind it if you need to. I know I'm going quick. I have to make sure to get it in under time limit. So I'm not going to read all of this. Basically, what you need to realize is, I hope you're reading this on your own, is that when the Fahrenheit temperature is greater than negative 31, you've reached the boiling point of chlorine. So when we take a look at the equation that translate Fahrenheit to Celsius, okay, we notice F is equal to 9/5 C plus 32. So what I want to do is I want to find what the Celsius boiling point is for chlorine. Since F is equal to this equation, I can take this equation and plug it in for F and get 9/5 C plus 32 is greater than negative 31. Okay? And I'm seeing now that I really don't have the time to go through all of this, so we can take a look at this in class closer. But if I solve this very, very quickly here, negative 63, remember to times by 5/9. And when I multiply that out, the 9 and the 5 cancel there, and C becomes greater than negative 35. All right. I hope that this works out for you, and we'll get the next two up here shortly. The next two are solving inequalities of compounds, solving inequalities that are compound, so intersections and unions. See you later. Bye. Bye.